We are going to study linear algebra. This course, this material is applied in all fields of mathematics, also in physics, also in engineering. And we use this as a tool. And if you understand it nicely, then you can apply this one for solving different type of problems. So today our discussion will be about introduction also, and also I will explain what is linear and nonlinear equations. And also we will discuss the system of linear equations. So first of all, we take the introduction. In introduction, as I mentioned that I just go to the geometry, and this thing, you know it, this is a line. A straight line. We used to say it's straight line or line. Just we add here two words, and this we just add AR. That means this is a linear. And when we say it is linear, it means it's something related with the line. So we know the equation. The equation is having two sides, they're balanced. And we have the equation of line. We have different type of equation of line. For example, we have y equal to mx, a equation of a line passing through the origin. We have y equal to mx plus c. And we have in the intercept c. When we take x equal to 0, y equal to c, the point is 0, c is passing to that point. Or we can write here different, we iterate here ax plus by equal to c. This is a very general form of the equation of the line. So we come in our mind that we are going to have the equations, which is of this type. I have two variables. Here the variables we are having here, variables are x and y. What about a, b, and c? We say a, b, and c are constants, are real numbers. And we say they are constants. So there must be some difference between a, b, and c. And we can mark the difference because they are all real numbers, are all constant, but a is coming with x and b, whereas a and b are coming with the variables. So when they are coming with the variables, we say these are coefficients. A and the b, we say they are coefficients, and where c is simple constant. In this way, I have introduced you the equation of line, and this is my equation in linear algebra. This is my equation. I'm having two variables. I can just extend this one to three variables. We can have an equation here, ax plus by plus cz equal to d. Now we're having three variables. Our variables here are a, b, and c, x, y, and z. And now again we can just define our coefficients. They are constant. A, b, c, and d are constants. But we can distinguish them between these two. We say a, b, and c are coming with the variables. We say coefficients. We say their coefficients are a, b, and c. And what about d? These are constant. These are real. This a, b, c, and d are real numbers, and they are constants. So I have introduced an equation with three variables, x, y, and z. So this I told you, this is equation of line. What about this equation? This equation of plane. The equation of plane. So this is the idea that how we get the equations. As I mentioned, we are having these two equations I defined. There's the equation of line and equation of plane. And these are my linear equations. What's the difference between this line and plane? I have one more equation of circle. I have the equation of circle as x square plus y square equal to c, or c square, or r square, sometimes we take. So c square. So this is my equation of circle. What's the difference between these two? The power of x and y, the power of a variable is 1. And the power of variable is 1, that means the equation is linear. If it's other than 1, that means non-linear. So we say this set of our linear equations. And the other equation which I have written, that is my non-linear equation. And we are going to study, in this case, on linear equation. Other non-linear equation, we have the in geometry, we're having x square upon a square plus y square upon b square is equal to 1. This is my equation of ellipse. I can have here y square is equal to 4ax. the equation of for a x equation of parabola. I can have the equation x square over a square minus y square over b square equal to 1. It's my equation of hyperbola. So these are all I need in future discussion, but I just mentioned this one. These all my equations are nonlinear. So we must be very clear. Any equation whose power is other than 1 will be nonlinear equation. It can be like this one. Xy equal to 1. This is also nonlinear. Y equal to root of x, also nonlinear, because the power changes. Here the power is 2, and here power is 1 by 2. We're having an equation like this one. X upon y equal to 1. This equation is also nonlinear equation. I hope it is clear to us that what are the linear equations and what are the nonlinear equations. And what we are going to do, we are studying only the linear equations. So we have defined one equation, that's a linear equation. So for example, I have two lines. I have two equations, 2x plus 4y is equal to 3. Another equation, 2x minus y equal to 5. There are two equations. When there are two equations, we say the system. We say here system of linear equations. Or simply we say linear system. We can just generalize these equations instead of writing the numbers to 2, 4, 3, 2, 1, minus 1, 3. We just write here. This is my a. I write a 1x, ax plus by. I just change this one. I write here a 11x plus a 12y is equal to b1. I just change my variables because I want to write more than one. So I have to define in such a way that I can write it. I have here a21x plus a22y equal to b2. This is my system of linear equation with two variables. My variables are x and y. Even I can change my variables. I can write this one as a11 x1 plus a12 x2 equal to b1. I have a21 x1 plus a22 x2 equal to b2. Just is a dummy. We can just change it because we can expand this one. We can have more than 100 variables or 1,000 variables. In this way, we can write on computer. We can just write a program and we can write them this way. But here we are limited. So we become unlimited in that one. Here our A's are coefficients. Our B's are variable. B's are constants. And our X are variable. So in this way, we can just expand our view that we can have more than two equations. Here we're having only two equations. We say system of equation, or linear system. I have defined two variables, two constants. We're having coefficients. Now we expand that one. And we say we're having three variables. And say my variables, I can take as a x, y, z. I can take as x1, x2, x3. Any type of variable can take. I take this one. When we're having limited number of variables, then we take this x, y, z. When we're having expansion of that one, like x, y, z, and then we want to take more, then we say x1, x2, x3, x4, x5, x6, x7, n number of variables. So if I want to write the equation in three variables, so my equation will be a11, x plus a12, y plus a13, z equal to b1. And then I'm having the second equation a21x, a22y plus a23z equal to b2. Then we're having a31x plus a32y plus a33z equal to b3. Now I know, now you are clear what are my a's and what are my b's. Because I explained you in the last example also that our a's are coefficient and our b's are constant and x, y, z are variable. Again, I write it here. What's our a's? Our a's are coefficients. What are our b's? Our b's are constants. And what is our xyz? Our xyz are our variables. In an equation, we know these a's and we know these b's. X, y, z, they are unknowns. We say it's variables, or we say unknown. The problem in linear algebra is that we want to find these unknowns in our problem, x, y, z, we want to find in our problem. We are given here the equations where our a's are known, our b's are known, and our unknowns are x, y, and z. And then we want to find the values of x and y, z. And here comes the linear algebra. And we discuss different methods, how we can find the value of x, y, and z. So these methods are by using the row reduction. And we say it's row operations, elementary row operations that we defined to solve our problem. And there are three numbers, row operations, elementary row operations. Number one, we can interchange two rows. Or two equations, you can say. This is my equation 1. Here is my equation 1. This is my equation 2. This is my equation 3. I can just change it. I can change 1 and 2. I replace 1 by 2. Doesn't make any difference. The value of x, y, z will be same. Result will not change. Number 2, we can multiply equation with a number. Non-zero number. The value of the system will not change. This is my system. This is my linear system. I want to solve it. Our system of linear equations. And here I am doing my row operations. My row operations is number 1. We can interchange two rows. I will multiply any row with any number, not zero, non-zero number. We say the value of system will not change. Number 3, we can add multiple of one equation to another. So again, this is my operation 1, this is my number 2, number 3. These are 3 elementary row operations. And you must remember this one, that with the help of these row operations, we are going to solve our problem. We're going to find the value of x, y, and z. That's our problem to solve it. And we have the tool for that one is the elementary row operations. Now I'm going to introduce the new concept. The concept of matrices is plural of matrix. What is a matrix? Matrix is a rectangular array of elements written in rows and columns. I have written 2 examples for you. One is example A. We have only the numbers. It's 1, minus 2, 3. This is my row. And this is here 2, 4, 6. And this is my column. This is my rows. There are 2 rows. And there are 3 columns, and they are all numbers. They are constants. They are numbers. But here we can say, because we say this row of elements, which contains numbers and also the function, which contains numbers and functions. So I have the example B, where we have the functions also. We have 3x, 2x squared, 1, root of x. These are my columns, and these are my rows. So we can write the size of the matrix. Size of the matrix is our rows, number of rows, and number of columns. You can see here, we having here 2 rows. We write here 2 multiply with 3. We say 2 by 3. This means 2 rows and 3 columns. And then we having here the number of rows is 1, 2, and 3. We say here 3 rows. And number of columns is 1, and this 2 columns. So I introduced two things here, that we can have a matrix which contains only the numbers. We have the matrix which have the numbers and the functions. And we have introduced the size of the matrix. Size of the matrix is number of rows multiplied by number of columns. We can just put here the sign for the numbers to make it more clear. Number of rows here, there are 2 rows, we say 2 by 3. Here number of rows are 3, we say 3 by 2. And on base of these numbers and on base of the rows, size of the rows, these we call as rectangular matrix. If the rows and the columns are same, we call it as a square matrix. Then depending upon the structure and the number of elements in the matrix, we have different name for this one. I will introduce you that one. So what I want to do, I want to write my equations in terms of the matrix. We have written the equation. For example, we have 3 equations. The next step will be, I'm going to change this one into the matrix. So I've just written here, linear system is having 3 equations. We have 3 variables x, y, and z. I want to write this one in terms of the matrix. When I want to write it, I just take the data out. I have here the data in the first row is 2, 3, 4, and 1. The second row is 1, minus 1, 1, and 5. And the third row is 3, 2, minus 1, and minus 10. So I just make in a box. So this become a matrix. This become a matrix. And then here I have the next matrix that contains the constant. And here I write my matrix of unknown, x, y, and z, and put here an equal sign. So I just wrote my 3 equations in terms of a matrix. And this my matrix is, this is my coefficients. They are my unknowns. These are my constants. In a very simple way, I just name each of the matrix. I name this matrix as A. I name the matrix of unknown as X. I may name the matrix with the constant as B. Now I can just write a very general equation for my linear system. That's A, X equal to B. A will be changing, B will be changing, S remain the same. So we can have different type of A here, different type of B here, and we can have new matrix, new equations, set of equations, and new matrix. So when we are having here, when we wrote this in terms of matrix, so further we can just define our systems in such a way that the things are very easy for us to write it and to solve it. So that's our next step. So we are just going to take this matrix another form where I have only data. I don't have x, y, and z. I write this one as, this is my A, I write here my B. My A is coefficients and my B are constant, and I just take the data. My first values are 2, in the first row 2, 3, 4, and 1. Then I have 1, minus 1, 1, and 5. I have here 3, 2, and minus 1, and minus 10. So this is my A and B. I just put a line here to separate my A's and B's. I give name to each of them. This form is my equation form. Linear system in equation form. This form is my matrix form. I just write my system in matrix form, and here I give a name, augmented matrix form. And we mostly use this augmented matrix form for our solving our problems. This is my row 1. This is my row 2. This is my row 3. So if I define my elementary row operations, now I can redefine my definitions with the equations. So I defined with the rows. So it's my first one is, in my augmented matrix form, I can interchange 2 rows. I can interchange 2 rows. Number 2, I can multiply row with a real number. With non-zero real number. When I say multiply, we can divide at the same time. Number 3, we can add multiple of a row to another. Inshallah, in next slide, I will use the next lecture, I will use the elementary row operation and give you the idea about the solving the system of linear equations. In that one, that will next. This was just the introduction. With introduction, I just defined what is the linear system, what is the linear equation, what is the linear system, and how to write in a matrix form, and give you the three forms: equation form, matrix form, and augmented matrix form. As I told you here, when you can see, we are independent of x, y, z. We can have here x1, x2, x3, any type of variables we can have, we can write. But we take the data and solve it. And at the end, we are going to write again in terms of the equation, and we can write our solution. That will, inshallah, our next lecture.